Hi everybody, very good evening and a warm welcome to Vedantu Enlite. What's up? How are you all? Hello everybody. Hi Shagun, hi Khushi, hello Krishna. What's up? What's up? How are you? Can you all see me and hear me? Am I audible and visible? I'm not able to see anything. Wait a second. Do you guys see me? Yes, yeah. Now I get to see. Yes. Hi, Alvin. Hi, SR. How are you, everybody? Okay, so guys, we are already done with one session of P block, and today we are going to do the other families of the P block. So this is the second session of P block. If you haven't watched the first one, I would request you all to please watch it because that's a part of class 11 P block, and this is going to be class 12 P block. Now you all know that, right, everybody? Yes. Hi Utkarsha. Hello everybody. Very good evening. Snake Mania, how are you? How are you? Welcome to Vedantu Enlite. What's up? So before I start with the session, first of all, my introduction. I am your master teacher Nabamita Ma'am, and I teach you inorganic chemistry in this channel. Yes, I do teach you. I can teach you physical and organic also because but right now Wasim sir is taking care of that. So maybe we will see what to do later on, isn't it? Yes. How are you all? How are you all? I believe that after Diwali holidays, this is my first live, right, after coming back. I don't think I have seen you all, yes? Oh no, we saw that day we had that collab session with Shimon sir and Shreya sir. Yes, at that time we were there. How was your day today? My day has been quite hectic today. So yeah, going good, I guess. Going good, I guess. Now I feel a little more energetic since I have a class with you all. Amazing. More and more students are coming. Guys, go call up your friends as well. I think that you all promised in that collab session, right, with Shimon sir and Shreya sir. You told me that you are going to call up your friends so that you are not gonna miss it, isn't it? Oh, first time in live session with you. That's amazing. Thank you so much for coming here. Okay, so let's begin, I guess. I think we should start it, right? I think we should start it. We shouldn't be going for any more delays. Yes, without much further ado, let's begin. Okay. So as I told you everybody, since you all are here, don't forget to like, share and subscribe if you are liking the session, isn't it? If you're liking the session, if you like the channel, because you know that this is the only official channel where JEE, NEET, 11th and 12th, everything is taught completely in English, no other language. Otherwise, you will find a lot of channels where things are taught in Hindi and all other languages. But this is the only channel where you are getting every detailed information in English. So do not forget to like, share and subscribe, okay? Now this is about me. You all know that my name is Nabamita Ma'am. However, mostly the students call me Nobita Ma'am. So you wanna call me Nobita Ma'am? Sure. Absolutely great. Go ahead. Okay, go ahead. Now, this changed, you know. So from Google Slides, when you download it into a PPT, this sometimes does happen. But anyway, don't worry. I'll let you know about what it is. So we are today going to talk about group 15 to group 18. Okay, if you have missed the previous session, my dear students, I have taught you about the boron family and the carbon family almost quite elaboratively. Okay, please go and watch it because you know that the P block questions will be coming from both the 11th standard as well as the 12th standard. So today we're going to start with this. Shall we, everybody? Are we ready? Are we ready? Yes. Thank you so much. Let's evolve. Thank you so much. So if we are ready, can I have some thumbs up just so that I know that you all are ready? Oh, by the way, please, for today's class, please have a notebook and a pen with you because it's really important that you all make notes with me. Otherwise, in today's class, we do have to remember a lot. We have to learn a lot of chemical reactions, and you know, right, even before I joined Enlite and the moment I was launched in Enlite, all of you told me that, ma'am, inorganic chemistry is such a dry subject. We don't even know how you're going to make interesting. So if you want me to make it interesting, I would request you all that please sit. If not, if you can't find a notebook, just have a piece of paper. Please, at least have a piece of paper. So that we go on and we make notes as well, okay? Otherwise, it's going to be very difficult for you all to learn the reactions at the end moment. Yeah? So please do that for me. So let's begin, everybody. Today we're going to start with group 15 elements first, okay? Now this group 15, what is it called? It's called as, like, you know, how my family would be known as, because my surname is Bhattacharji, right? So Nabamita Bhattacharya, people will be like, okay, let's go to Bhattacharya family's house, right? The family name, yes, the family name is always there. So this in here, this nitrogen is basically the family name. So we call it as nitrogen family. What do we call it? Nitrogen family. Now you all are going to ask me, ma'am, how do we remember this? How do we remember all of this? Yes, how are we going to remember it? Okay, let me tell. Let's learn it as, write it down. Nana Patekar and Nana Patekar, Aishwarya are from South Bombay B town. Okay. How do we remember it? We remember it as, see, in Hindi there are a lot of other things that you will see, but in English I think this is the easiest one that I could find. I mean, I could think of. So here we go. Write it. It is, why is it not? Okay. Nana Patekar. Okay. Nana Patekar, Aishwarya are from South Bombay B town. B town is Bollywood, isn't it? B town is Bollywood. Yes. So can you all remember this? Can you all remember this? So what do we have? We have nitrogen, phosphorus. Yes. What do we have? Arsenic. We have antimony and we have bismuth. Yes, everybody. Is this clear? This is easy to remember, everyone. Shagun. Yes. Right? Great. Amazing. Okay. So this is your nitrogen family. So we are going to talk about this. Of course. Now in the P block elements, group 15 to group 18. 18 is all noble gases that we are going to learn at the end. But right now group 15 to group 17 we will finish. Yes, this is easy, everybody. Will you all be able to remember it? Nana Patekar, Aishwarya are from South Bombay B town. B town is Bollywood basically. Yeah, Bollywood people keep writing it B town, B town. So B town is basically your bismuth. B town, bismuth. South Bombay SB. Okay. Yes. Arsenic is Aishwarya. Nana Patekar is nitrogen, phosphorus. Cool. All right. Moving on now. Moving on, let's talk about nitrogen family. Now in this family, when you take a look at it, one glance, and you will be able to understand that these two, the first two elements, these are non-metals, right? These are non-metals, as we can see. Nitrogen and phosphorus are non-metals. Now if you take a look at arsenic and antimony, these are what? These are metalloids. And finally bismuth is a metal. So if I ask you what happens to the property metallic character? We go down the group, what happens to the metallic character? Anybody, can I have the answer in the chat box, everyone? Tell me, what happens to the metallic character? Does it increase or decrease along the group? Is it lagging? Feels like it's lagging. What's going on? It's lagging, isn't it? Video is paused. Why? I am. Edit. Can hear you but can't see you. Okay, there is something wrong. That means, wait a second, let me try. This is not working. Still not able to see me, right? I know the screen is stuck. I don't know what to do. This is so weird. Draw. You all can see me now, no? Okay, great, great. So sorry, so sorry. Hi. Happened last day too in Wasim sirs. Acha. Okay. Yeah. Hi Shagun, I'm back. Did it just happen again?
Tell them that 2 minutes of time.
Give me 2 minutes. I'll just sort it out and be back, okay? Give me 2 minutes. 2 minutes. Check, check. I really hope it works now. I really, really hope that it works this time. Yeah, I'm back again. Hi. I really hope that this does not happen again. Am I audible and visible now? Hi, Singham. Hi. Hi, Kaushal. Oh, finally, my students are here. I think Kaushal and Singham, I have been seeing you both from the beginning of from my beginning, from the day I started my Enlite journey, isn't it? Hi, thank you, Ashima ma'am. Thank you. Audible and visible, perfect. Okay, great. Okay, let's begin again then. Okay, let's move back and then let's begin again. So, what I was telling you, I was talking about the nitrogen family, isn't it? I was talking about the nitrogen family. I told you that we are going to start with the nitrogen family right now, right? The first thing that we are going to learn about is nitrogen family. And what was, I asked you a question. Yes, I asked you a question. And the question was that what will happen to the metallic character? Yes, what will happen to the metallic character, right? Just look at this table and then tell me what will happen to the metallic character as we move down in the group. Tell me, everybody. I need this answer from you all. I need this answer from you all. Yes, it's my status. Shagun, everybody, come on, tell me. What is the metallic character? Increases. Absolutely right. That's exactly the answer that I was looking for. Yes, the metallic character, it will increase because we can see that it starts from non-metals. Yes, these two elements are non-metals. Then we come to metalloids and then we come to bismuth, which is a metal, right? So obviously it increases down the group. Absolutely. Now, while I was teaching you periodic properties, if you remember, in periodic properties, there was one thing that I kept telling you. It was periodic. The properties kept repeating itself after some time, isn't it? And in here also, when we take a look at things, we see that yes, there are properties that do repeat. Okay, there are properties that actually do repeat. So let's talk about, now we are not only going to talk about the physical properties. In fact, I am going to skip the physical properties right now because I think that the physical properties, no bacha, let me tell you something. The physical properties are actually quite easy, and if you just go through the NCERT book once, you will be able to understand. But I'm not saying that I'm not going to teach you. I'm not going to say that, okay? What I mean to say is, because your JEE exams are, you never know when the cloud will burst. So let's just finish those things that are absolutely required for us. And for that matter, the chemical properties, how the nitrogen family forms different compounds, we have to study that first, okay? So can we study these things first, and then, like I told you, what was my strategy? I'll finish everything first once and then we will come back and we will study everything elaborately, right? So we are going to start with the compounds and their properties. Is that okay, everybody? I will come back. Anyway, I have taken some of it in the periodic properties as well, right? So now let's come back here, okay? Thank you, Shagun. Thank you so much. Okay. So when we take a look at hydrides, okay, what are hydrides? Everybody, you need to understand this. What are hydrides, okay? Hydrides are basically this, EH3. That means E is the element, okay? E is the element. As you can see now, see, NH3, PH3, ASH3, SBH3, BiH3, all of them are what? EH3. Makes sense now? EH3, does it make sense? Yes? Absolutely similar? Yes? So this is your hydride. Now when it comes to the hydride, we see one thing, that there are properties here as well which kind of are similar for them. Okay, which are kind of similar for them. Stability, we see that maximum stability is here. For NH3, the maximum stability is here. For ammonia has the maximum stability. But here, you do not get to see so much. Atomic number of bismuth. Do you want to calculate? How about you calculate? See, nobody actually learns all of these, yeah? Nobody actually learns all of this, but you can always calculate. I'll tell you a magic number, okay? I'll tell you a magic number. Let's write it down here. What did I say? Nana Patekar, Aishwarya are from South Bombay, Beta. So there is a magic number which is basically 288, 16, okay? 288, 16, 16, 32. I think it's this. I think it's this. Now calculate and check it out once. Now calculate and check it out once. Nobody has to remember all of this, but you can always calculate. Try it. Try it. I'm telling you this. Come on. So what you're going to do is you're going to add. You're going to add. Okay? These are the magic numbers. These are the magic numbers that you are going to add. Anyway, okay? Calculate. See if it makes sense or not. See if it makes sense or not, and then tell me. Vinayak, will you be able to calculate it and tell me? Now check if it is right, Sai Kolu. Check if it is right. Thank you, Vinayak. Thank you so much. Elvin, you have also told me that. And now tell me that if it is right or not. When you are calculating from the magic number, is it absolutely correct or not? Tell me this. Yes, absolutely. So now will you all remember this? For every group you can do this, okay? For every family you can do this. This is your magic number, 288, 16, 16, 32. Just remember this, okay? Just remember this. You will be able to do it, okay? So 2 is for the from first to the second period. When you're coming from first to the second period, that's when you add 2. Otherwise, you add 8, 8, 16, 16, 32, okay? That's it. Clear? Now, this is very important for your JEE and NEET students, Baba. Not really for your board exams, but this is very important for your JEE. So this magic number, if you remember during your JEE exam or your NEET exams, what will happen? Calculations will be easier. Yes, and your answers will come out like this. From in a snap, you will get it. Correct? Okay. I'm going to rub this now. Okay. I'm going to rub this now. Because we don't really need it right now. Where is this? What is happening today? Just a minute, guys. Yes. Now this board is giving me problems. Alright, yeah. So as we were talking about now. Yes. Okay, we were talking about stability. Stability we have understood, right? Stability we have understood that as we go down the group, it decreases. So maximum, how you write these numbers? Elvin, that I'll have to teach you in periodic properties again. Okay, this comes from the periodic properties, the periodic table chapter. From there we know this. Okay, 2, 8, 8, 16, 16, 32. Just remember this, yeah. Just remember this. It's very easy, right, to remember these numbers. Just remember these numbers and keep adding. You will find it. Okay. For one group, if you know, for one family, if you just know the atomic number of nitrogen, rest all of it you can calculate. Correct? Anyway, moving on, everybody. Yeah. So I was talking to you about stability. So we all understand that NH3 ammonia is the most stable one, right? It is most stable one. But about bismuth, we can't really say that. It's not that stable, isn't it? It's not that stable. Now again, basic character. Again, basic character also you will see that it is maximum for NH3. Solubility, once again same. Now bond angle. What do we mean by bond angle, bacha? Anybody? Any idea what do we mean by bond angle? Bond angle is basically if I am nitrogen, here is one hydrogen, here is one hydrogen. Yes, so what will I do? I'll try to bring them closer. And we will see that for nitrogen, it is the maximum. So when I pull them closer, being nitrogen here, what will I do? I will try to pull them. When I try to pull them, this hydrogen and this hydrogen, they will also try to repel each other. So this becomes your bond angle, isn't it? This becomes your bond angle. And we see that the bond angle is also maximum in case of ammonia. Am I right, everybody? And absolutely right, Sudha. Absolutely. But do you understand this crude manner that I am teaching you? Because it is easier to remember these, right? Simple and sophisticated language, nobody understands. But if I make it fun for you, everybody will be like, yay, we remember it. Anyway. Also the strength of the MH bond, that is also maximum here. Strength of the MH bond, or let's write EH. Yes, why complicate? Let's write EH. The strength of the EH bond or the MH bond is also maximum here. Why? Small size. Small size, this is big size. Obviously we know that the stronger. How many of you do you watch this series Friends? Have you all watched Friends series where there is Joey, Ross, Rachel and all of them are there? How many of you have watched the series Friends? Anybody, have you all watched it? Or maybe you have watched that episode where Joey wants to poke someone. Remember, he makes a huge he makes a huge poking device with chopsticks. Remember? So tell me something. You make a huge device, a poking device with chopstick. Don't you think that it will be very easy to break it? Very easy to break it, right? Yes? No, but if I have a very small pencil, will I be able to break it? Ajay, theek, you haven't watched Friends. How about you have a long pencil like this and you have a small pencil. A small pencil, will you be able to break small pencil? Very tough. Very tough. Hi Arvind Kalia sir. Hello, thank you so much. It will be very tough to break it, right? But if you have a longer pencil, you will be able to easily break it, isn't it? So that's exactly what happens here. NH3, small size, small bond. Yes. But here it is bigger. That's why. Reducing character, however, what happens is for bismuth. Yes, for bismuth it is the highest. For BiH3 it is the highest. What is reducing character? What do you mean by reducing character? Sanjay, not right now. Please focus in the class, bacha. Yes, anyway, periodic table this P block has taken a very long gap. I don't want to. Today, let's not waste much time. Yes, we will talk at the end, okay? Come on, guys, I need your answer. Yes, reducing character. What do we mean by reducing character? What have we learnt about oxidation and reduction? In the in the lower grades, we have read about it, na? Reduces other, but how? How does it reduce? How does it reduce? How does it reduce? Come on. नहीं सर, ऐसा बिल्कुल भी नहीं है. How many part of this? Two. Okay, very good. I can see mixed answers by gaining hydrogen and electrons. Removal of oxygen, oxidize. Very good. Yes. Reducing is basically gain of hydrogen and loss of oxygen. Yes. Oxidized itself. Absolutely right. So from here you can absolutely see that, right? You can definitely see it, isn't it? Very good, Sanjay Singh. Thank you so much, Arvind sir. Thank you so much. Chalo, moving on now. Let's move on from here. Now we are going to talk about a different compound which is called a dinitrogen. Now, see, it looks very sophisticated, but what is it? What is it? If I tell you, you will be like, oh, seriously, ma'am, this is only that is. Dinitrogen. Bro, dinitrogen is what? N triple bond N. This is your dinitrogen. Haven't you seen this? I'm pretty sure you have seen it in lot of places. Yes, you have seen it in lot of places. So dinitrogen, we are going to talk about the preparation. Everybody, are you all ready with your pen and paper? I've told you today, please sit with pen and paper. Yes, please sit with pen and paper. We have to learn the preparation. How do we prepare? So there are like, in every compound, there are like 3 to 4 reactions, 3 to 4 chemical reactions. We have to understand this, okay? So I'll tell you, Sanjay, about organic chemistry, I'm not very sure, but right now Wasim sir is taking care of your organic chemistry and physical chemistry. I would like to focus on inorganic because I know that inorganic has a weightage around 34%, and I would like to make it interesting for you, knowing that it's a dry subject. I felt the same thing when I was studying it, right? So I just want to focus on inorganic right now. We will see what can be done about organic. But right now I know that Wasim sir is there for you. He is also there in this channel, right? He's going to take care of physical and organic chemistry. Okay? Alright. Come on. Everybody, are you all there? We will see, Sanjay, okay? We will see. We will see about it. I can't promise right now. We will see what can be done, okay? We will see what can be done. Anyway, come on. Back. Focus. I need your focus, everybody. This is very important. This is where all the questions in JEE NEET, all of it will come. So please, focus up. Do you all have your pen and paper, everybody? I need you all to have a pen and paper. Okay. Now, thanks, Kaushal. Thank you so much, everybody, that you all are being so supportive for me. Alright, so preparation. What are we taking? We are taking ammonium chloride. It's very easy. Okay, very easy. You know what? I'm going to show you all of them together. look at both the reactions. Look at both the reactions. I'm going to just give you tricks, okay? I need you all to understand the tricks, then it is going to be easy. So what are common factors here? See, we see that here it is heated, here also it is heated, correct? Yes. N2, N2, common products, yes. H2O, H2O, common products, yes. But here, only thing that is different is NaCl and chromium oxide. Why? Because obviously here you are taking ammonium chloride and sodium nitrate and you get NaCl here. But here you are taking ammonium dichromate. You already see that Cr2O7 is here. So from Cr2O7, what do you get? You are getting chromium oxide. That's it. Easy. That's it. Easy. So what are we doing for the preparation of dinitrogen? There are two things that we can take. One is ammonium chloride and one is ammonium dichromate. That's it. Ammonium chloride, you take ammonium chloride, you are going to get salt and water. You take ammonium dichromate, you are going to get chromium oxide and water. Easy. These two reactions right now. Write it right now in your paper. And make notes properly, okay? Write these similar products, okay, the similar things, just like how it is written here with red, just write these with a different pen, these with a different pen color you write, other things you can write it with blue or black or whatever. Easy peasy, biryani is tasty. That's what we say, okay? Easy peasy, biryani is tasty. Correct? Got it? Easy? Thank you so much, John. Thank you so much. Okay, this is clear? Preparation of dinitrogen, very easy. What are we taking? Okay, now I'm going to ask you. Let's move from here. Now I'm going to ask you. Let's move from here. Tell me, what are the two things that we can take to prepare dinitrogen? In the chat box, I need answer. No problem, John. It's okay. It's okay, John. It's okay. You can watch the this thing from Rewind. Yes, tell me. Everybody, what are the two things that we can take to prepare dinitrogen? Oh yeah, I love biryani. Ammonium chloride and what else? What else? Come on, quickly. I only see Kaushal answering, Baba. Nobody else is listening or what? Sodium. Shagun? I just taught you, you made mistake now only. Huh? No. What are we taking? We are taking ammonium chloride and we are taking ammonium dichromate. These are the two things, okay? These are the two things. Ammonium chloride will give you H2O and NaCl. Ammonium dichromate will give you chromium oxide, water and nitrogen. I mean dinitrogen. Yes. Finally, there is another reaction also which is very easy. I mean, these two looks a little, these two looks like, ma'am, how to remember all of these for JEE and NEET, ma'am. My JEE is gone, ma'am. I will not be able to do it and all of these. That's what you feel, but actually it is very easy. But this, if you look at this, then you'll be like, Chha, these questions come for JEE and NEET or what? This is so easy. How can this come for JEE and NEET, right? This is very easy. So, you take barium azide and what do you get? You get dinitrogen and barium. That's it. That's it. What do you get? Barium azide you take and you get dinitrogen and barium. Very easy. Now, properties of dinitrogen. How many of you... Okay. Let's go back to lower grades, everyone. Okay, let's go back to lower grades. Do you remember studying about something called as nitrogen cycle during your younger days? Remember? Nitrogen cycle. You must have read about nitrogen cycle when you were younger. And in nitrogen cycle, do you remember there was a step called as nitrogen fixation? And do you remember that there had to be some bacteria which had to work, or there had to be lightning which had to, break the nitrogen in biology? Let's connect it now. So what do you get to, what idea do you get about dinitrogen? Do you feel like dinitrogen is probably not too reactive in nature? It feels like that, no? Yes? It is not reactive in nature because there are triple bond and it is what existing together. Yes? And that is why you had some bacteria which had to work hard to break them, or you had to have a lightning, okay? Or you had to have some lightning which could break it. So you see what is written? High bond enthalpy, inert at room temperature, triple bond. To break that bond, it will require a lot of energy, right? So obviously it makes sense. High bond enthalpy and it is inert at room temperature, isn't it? It is inert at room temperature. Absolutely correct. Okay. Now, moving on. let's understand some reactions at high temperature, okay? Some reactions at high temperature with dinitrogen, alright? So, let's take a look at it. There is lithium. Lithium reacts with dinitrogen, and what does it form? Lithium nitride, yes? Alright, then what do we have? We have magnesium. Magnesium also reacts with dinitrogen and forms magnesium nitride, yes? Now, which are the metals that react? Which are the metals that react? One more example. I don't know if you have seen it. Have you all watched Narcos Netflix series? Narcos Netflix series that is there. I'm pretty sure that you don't watch so many series, but just asking, top of my head, I mean, has anybody watched it? ललित कुमार हिंदी बोल तो लूँ बट चैनल है इंग्लिश का, ठीक है? तो इफ़ यू आर लुकिंग फॉर हिंदी, आई वुड रिक्वेस्ट you all that please go to NEET Made Easy or other channels that Vedantu has where you can read in Hindi, bacha. This is definitely going to be an English channel and I'm going to teach in English, okay? Alright? NEET motivation in Tamil, we will talk about it. Yes, how to remember all reactions. Sudha, I just taught you this thing, no? Naruto and all, no. Have you watched Narcos? Money Heist? Okay, so there is a series called, Narcos, and Narcos is all about, being in the drug business and everything, right? Narcos is all about being in the drug business and everything. So in the drug business, what they have is, they have different gangster groups, right? They have different gangster groups. And in that gangster group, there is one gangster group which is called as Kali Cartel. Okay, what is it? C-A-L-I, Kali Cartel. What is it? Cartel is basically a group of gangsters, okay? Cartel is basically a group of gangsters. So you have Kali Cartel or we can, how do we remember it? We can remember it, see. Kali Cartel Mega Gangstar, okay? Can we write it like this? Mega Gangstar. So see, you will be able to remember it. Calcium, lithium and magnesium, Mega Gangstar. Yes, do we understand this? Kali Cartel, Mega Gangstar. That's how we remember which are the metals that react with dinitrogen, okay? Got it, everybody? Easy? Easy? This is how we will remember it, okay? Moving on. Now let's go to ammonia. Everybody ready for ammonia? Yes? Again, here also there will be 2 to 3 reactions, okay? So, ammonia can be also synthesized, as in prepared on a very small scale. Why only these? That's how they react. You have to remember now. Okay? That's how it is. Now you have to remember. Okay? Yes. Now, small scale synthesis. So, basically, you can prepare ammonia. Okay? My video is slightly blurred, is it? Thank you. Thank you, Chenukwal. Let me see once. No, it's not. It's absolutely fine. I don't see. Oh my God. Hi, Indira. So happy to see you. My goodness. So happy to see you. Such a long time. I can't believe it. You guys see Indira? Indira was my student in class 8. I had taught her in class 8 and now she is in, I think, 11th standard. So today she is here. So happy to see you. Anyway, alright, moving ahead everybody. So ammonia can be prepared on a very small scale, okay? How can we do that? Yes, old student. We can take ammonium chloride. We will take ammonium chloride and we will add calcium chloride. And what will we get? We will get ammonia. And we will get some water and calcium chloride. Again, this is easy. This you must have seen it also. In some or the other places you must have seen it, right? In some book in your lower grades, somewhere or the other you must have seen it, okay? Will you save this live? Yeah, Conan, this will be saved, okay? This will be saved. Absolutely. Any courses for JEE in 2 months? Hi Malanka, we will definitely do this. There will be some, we told you, right? This channel will be like full of hustle bustle. We will complete everything. Don't worry. Alright, yes. Now moving on. Again, can we do the same trick, everybody? Sudha, you are asking me, ma'am, how to remember all of it. Same trick, bacha. For ammonia, write it down. See, NH3, common. H2O, common. Now see, what are the 2 things that we are taking? We are taking ammonium chloride, ammonium sulfate. Everybody, ammonium chloride, ammonium sulfate. What do we get? If we take ammonium chloride, we will get calcium chloride. If we take ammonium sulfate, we will get sodium sulfate. See, do you understand this? Yes, everybody? Are you all able to see this? Common, see. Small scale synthesis, common, absolutely common. See, NH3, NH3, H2O, H2O. This if you remember, and then you have to remember that ammonium chloride, ammonium sulfate. These are the two things you are taking. Easy. Are you writing it down? Whatever I am saying, please write it down. Otherwise, later on when you read your notes, you will not be able to understand anything. You will not be able to understand anything. And these reactions are important. These are where questions will be coming from. Later we all think that, can't really do, ma'am. These reactions are killing my head, ma'am. We will not be able to do it, ma'am. Oh, how should we study, ma'am? And all of it. So, no. Okay? Chalo, moving on. Okay? Moving on. Now let's talk about large scale synthesis. And somebody was asking me, ma'am, large scale synthesis, how does this happen? Yes, somebody asked me about Haber's process. Absolutely. Haber's process is for large scale synthesis. Now tell me, do you even have to remember this? Do you even have to remember this? Huh? This feels like, ma'am, we studied this in class 6 or 7, ma'am. Why are you teaching this to us right now? But see, this is what it is. Haber's process, that's it. Nitrogen, hydrogen, ammonia. I mean, come on, what is even there to learn it, Sudha? You understand? So wherever you need tricks, I'm telling you. But this, I don't think you even need to like say it 5 times to remember it. One time you see this, you will be like, that's it. That's your Haber's process. Yes, ammonia can also be prepared by Haber's process. Okay. So Hema, please take a look at it. Haber's process is for large scale synthesis. Okay. And I also taught you the small scale synthesis, which was this. Okay. This was your small scale synthesis. Alright. Yes. Okay. Moving on from Haber's process, everybody, do we understand Haber's process? Now let's take a look at some of the reactions of ammonia. Okay, so what are we going to take? Again, take a look at this as well. Take a look at this as well. Okay, very, very, very important. Here, this one again is very easy. Yes, you take ammonia, mix it with water. What are you getting? You are getting NH4 and you are getting OH minus. Okay. Not understand. Lalit, kya nahi samajh aa raha? What is it that you are not understanding? Bacha, I am teaching you about properties of compounds that the nitrogen family forms. Okay. Yes. Now, very important. Before this, Agilan, the questions that you are asking is very basic. So, you know what we will have to do? Can you please be with me right now? Okay, be with me right now. I promise you that once we have finished the JEE NEET and all of these parts, once we have finished with the chemical properties, once we have finished with all the chapters, let me complete your syllabus once. After that, we will come back and we will definitely talk to you elaborately about everything. Is that okay, Agilan? Right now, please focus on what I'm teaching, sweetheart, okay? It'll be really helpful for both of us. For both of us, it'll be really helpful, okay? Alright, now before this, before P block, what is the chapter that we read, my dear students? Coordination compounds. Coordination compounds, isn't it? Take a look at it. Do you see something like coordination compound here? Do you see something like coordination compound here? Yes. So ammonia, when it reacts with copper, what does it form? It forms a, see, what is it forming? It's forming tetraamine copper, right? Tetraamine copper, isn't it? So do you see it? Absolutely, believer, you will be able to master it, don't worry. Okay? Alright, now let's go to nitric acid. See, we have completed already 2 compounds are completed, everyone. We're going quite fast, okay? Let's go faster. Let's go faster. We have to finish it. Now let's go to nitric acid. Yes, what is nitric acid? HNO3. So let's talk about the preparation of nitric acid, everyone, okay? इसका नाम क्या होगा? किसका नाम क्या होगा? This coordination compound, tetraamine copper. I told you already. Tetraamine copper. Okay. Anyway, nitric acid. Yes. HNO3. We need coordination compound. Already taught Kirtan. All coordination compound is done. Please check it out. It's there in the channel. Okay. There in the channel. No problem. It's okay. Acha. Moving on, everybody. Moving on, everyone. Take a look at it. So we for laboratory preparation of nitric acid, we are going to take sodium nitrate. Mix it with sulfuric acid. This is sulfuric acid, H2SO4, sulfuric acid, okay? We're going to mix it with sulfuric acid. What do we get? We get sodium bisulfate and nitric acid, okay? Alright, and nitric acid. Shagun, I'll give you the notes. Don't worry. You join the Telegram channel, I'll give you the notes, okay? Yes? Okay. Now large scale synthesis. For large scale synthesis, this is Oswald's process. This is very easy. This is very easy. Take a look at it. Okay? Take a look at it. Let me bring all this thing. Now, so what do we need is, we need to take ammonia. From ammonia, we need to bring HNO3. Right? We are taking ammonia and we are going to get nitric acid, isn't it? So let's see. Very easy. See. Ammonia, add oxygen. Ammonia, add oxygen. Okay? Add oxygen. What do you get? You get nitric oxide. Now you take this nitric oxide, again add oxygen. What do you get? Nitrogen dioxide. Now you take nitrogen dioxide and this water that is there, add that. What do you get? Nitric acid. Easy? Easy, everyone? Got it? What did we do? We took ammonia, added oxygen, nitric oxide. Nitric oxide, added oxygen, nitrogen dioxide. Nitrogen dioxide, added in water, nitric acid. That's it. That's it. That's the trick. That's the trick. So 2 times you are adding oxygen and in the final one you add water. That's it. That's it. You get your nitric acid. And this is your Oswald's process. Okay? Yes? Shagun got it? Right. Now chemical reactions of nitric acid. How does nitric acid react with copper? Now in this case, so we are going to talk about 2 metals. Okay? We are going to talk about copper as well as zinc. We want to know how does nitric acid react with copper and how does nitric acid react with zinc. We are going to talk about both. Now in both the cases, we will take dilute nitric acid and we will take concentrated nitric acid. Okay? Alright. Again, it's going to be super easy. See, we are taking copper. Copper is common. Copper is common. Nitric acid is common, but in here it is dilute nitric acid and in here it is concentrated nitric acid. So when you take nitric acid diluted, what do you get? You get nitric oxide. Okay? You get nitric oxide. But when you take concentrated nitric acid, you get nitrogen dioxide. Understanding? Understanding the difference? But see, copper nitrate, same, absolutely same. Only thing that changes is nitric oxide and nitrogen dioxide. That's it. That's the only difference. Baki, see, water, common, absolutely common, similar. You have done this in salt analysis. You must have. Similar, this you understand. Again, are you all writing? I'm going to ask you all, are you all writing? Please do write it in a piece of paper. Right now, whatever I'm saying, underline and write it. So that the moment you are going for your exam, one glance and you will be able to understand it from your notes, what you have written and what you have studied. Yes, please do it. Yes, please no. NEET ke log de. Yes, Maheen, absolutely. Why not? NEET and JEE. This channel is Vedantu Enlite JEE NEET, right? So for both of them, okay? Moving on. Now let's talk about zinc. Again, for zinc, what will we see? For zinc also, we will take dilute as well as concentrated. Now, remember, Shreya sir and I, we took a collab session and what we spoke about laughing gas and many of you had given me wrong answers. Remember? Yes. That day, all my impression went down in front of Shreya sir. But today I'm going to teach you, and please from now on do not forget which is laughing gas. Laughing gas is nitrous oxide, N2O. When zinc reacts with dilute nitric acid, you get nitrous oxide. Okay? You get nitrous oxide. But if zinc reacts with concentrated nitric acid, you will get nitrogen dioxide. Once again, another trick, everybody. Do you see that nitrogen dioxide for concentrated? Yes. Nitrogen dioxide for concentrated. Do you see? Even when it was reacting with copper, when concentrated nitric acid was reacting with copper, there also you got nitrogen dioxide, and here also you are getting nitrogen dioxide. Another trick. Told you. Shagun, is this clear now? Is it easy? Sudha, you were asking how to remember. See, these are the tricks that you have to remember. Write it down properly, okay? Write it down properly. Highlight them with the same color so that you understand. Moving on. Now let's go to phosphorus allotropic forms. Okay. My dear students, put it in your head that there are going to be questions from this. Not only this, there are going to be questions from oxo acids that I will teach you in some time, and that you have to understand. You have to learn the structures. For that also I'll give you a trick, don't worry. So phosphorus allotropic forms. Now phosphorus exists in 3 allotropic forms. Okay, what are it? White, red, black. White, red, black. Okay, these are the phosphorus allotropic forms. Now out of them, the white one is dangerous. Okay, white one is radioactive. Yes, white one is highly reactive. Okay, it glows in the dark as well. Okay, it glows in the dark as well, and it readily catches fire in did I say radioactive? Sorry, not radioactive, not really radioactive, but it's highly reactive. Sorry, it readily catches fire. And give dense white color fumes. Okay, it will give you dense white color fumes. All right, that's about white phosphorus. Now, take a look at this. See, you take P4, reacts with oxygen, forms phosphorus pentoxide. Okay, phosphorus pentoxide. Moving on. What about the red phosphorus then? Where do you get to see the red phosphorus? Everybody has seen the red phosphorus, yeah? Where do you get to see the red phosphorus, everyone? The red phosphorus is seen in the matchsticks, isn't it? It is less reactive and it has a polymeric structure. See, this is polymeric structure only, right? It's repeating units. Repeating units, see? Yes? So this is your polymeric structure. Matchsticks, absolutely right. Yes, absolutely right. White phosphorus burns is highly reactive, bacha. Yes, Suresh, it's highly reactive, okay? And it is your, so okay, these are the things that we have learnt about red phosphorus, okay? Now moving on, what about black phosphorus? You know what? The black phosphorus is actually the most stable one. The black phosphorus is actually the most stable one, and you can heat the black phosphorus at 473 Kelvin and you will get maybe, no, sorry. Black phosphorus is the most stable one. I'm not lying, yes. Did I make a mistake? No. Yeah, I'm right. I'm right. Sometimes it gets a little confusing, okay? So the black phosphorus, it might come in your board exam also. It might come that which one is the most stable one. You have to say black phosphorus, okay? You have to say black phosphorus. Got it, everybody? Yes, matchstick, absolutely right. Shagun, yes, no, what? No, what? No for what, bacha? What are you saying no for? Good evening, Guddu. Okay. Now we move on towards phosphine. Everybody, please write down this. Write down the formula for phosphine. I want to see how many of you have actually paid attention. I want to see. I wasn't, right? Yeah, I wasn't. Yeah. Please write down the formula of phosphine. Come on. I want to see. Are you all even listening to me or not? What is phosphine? Okay, I'm waiting. Let's see who writes it down. Come on. Still don't see any answer. Very good. Thank you, Singham. Thank you. Yes, absolutely right. Okay, let's go forward. Yes, phosphine is pH3. Phosphine is pH3. So how is phosphine prepared? Again another reaction, everyone. We are going to take calcium phosphide and we will put it in water. We will get phosphine and we will get calcium hydroxide. Okay. Alright. Or you can also take phosphorus. and you can mix it with sodium hydroxide and water and you will get phosphine again. Alright. You will get phosphine and you will get sodium hypophosphite. Okay. This is here. This thing, no. From Google Slides to this thing. Yes, Sneha. Oh my God. Very good. So, Sneha, that means that you have studied it already, huh? Phosphine has a rotten smell. Absolutely right. It has a rotten smell. It smells very, very, very bad. Okay. Phosphine smells very bad. Okay. Now, let's talk about chemical reactions of phosphine. Alright. Yes. So, chemical reactions of phosphine. Okay. This is very easy. HBr. What do you get? Phosphonium bromide. Easy. Yes. Hydrobromic acid, you take phosphine and you make it react with hydrobromic acid. What will you get? You will get phosphonium bromide. Now if you take phosphine and if you make it react with copper sulfate, you will get copper phosphide and sulfuric acid. This you will have to remember. There is no real, I couldn't find a trick here to learn this. So write it down and remember it. it, okay? Write it down and remember it. There's nothing much that I can do. But, one thing that I can say is it reacts in the similar manner. Be it copper or be it mercury or be it silver, it also reacts with silver. Yes, it also reacts with silver. So be it mercury, be it silver, be it copper, it reacts like this only, okay? See, everywhere you will get mercury phosphide, copper phosphide, and you are getting an acid. You're getting an acid out, okay? You're getting an acid out. Alright, guys, am I audible and visible? For some reason, I am not able to see any chat. Am I here or not? Am I here or not, guys? There are some problems, that's why I'm a little scared. I hope it's not stuck again. Is it stuck again? Okay, I'm here. Great then. Alright, I'm here. Now we go to phosphorus halides. Somebody was asking about halides, I believe. Somebody was asking about halides some time back. Yes, okay. So we have come to halides, okay. We have come to phosphorus. Perfectly. I am here. Great. Okay. Thank you so much. That means that you guys are actually sitting here and listening, huh? Great. Amazing. Very good, kids. Okay. Phosphorus halides, okay. So, what about them? Phosphorus, and acha. Okay, one more thing. One question that I have to ask you. This question is usually asked in your board exam. Now, phosphorus, take a look at it. It forms phosphorus trichloride and it forms phosphorus pentachloride. Why is it that we did not have to study about this in case of nitrogen? Why is it that for nitrogen we did not see any pentachloride? We could only see NH3 ammonia, only like, trichloride or trihydride. Why is that so? Why is it that only phosphorus is able to form pentachloride and not nitrogen? Any idea? Need your answers. Come on. Need your answers, my dear students. This might come in your board exam. If it does, then please write, okay? Please, due to D block, but D block, phosphorus is in D block, Singham. You are going in the right direction, but I need you to give me a little perfect answer. Glory, you are a little late, but it's okay, no problem. You can definitely watch it from the beginning, isn't it? No problem. Okay, let me tell you. Don't know? Okay, let me tell you. Basically, it forms phosphorus pentachloride and nitrogen cannot form pentachloride. That's because of absence of, nitrogen is very small, no? Nitrogen is very small, yes? What is it? 2s2, 2p3. Isn't it 2s2, 2p3? In case of 2s2, 2p3, the d orbitals are not even introduced. So that means that nitrogen does not have any vacant d orbitals. But in case of phosphorus, 3s2, 3p3, right? So there is, Udayagiri, very good, absence of vacant d orbitals. Okay, can you write it down? I don't think me writing it down here will make sense. Everybody write it down. This may come in your board exam. It usually does. Okay. In most of the schools, if you see the question paper, this usually does come. So please write it down. Okay. Due to absence of vacant d orbitals, nitrogen cannot form a pentachloride, but phosphorus does. Okay. Phosphorus does. Alright. Is this clear, everybody? Can I get some thumbs up, everyone? Let's move on towards preparation. Okay. Almost correct. That's why I told you. You're going in the right direction, but just a little bit perfect answer. That's all I needed. Okay. So for preparation of phosphorus trichloride, what do we see? We have P4 plus 6Cl2. It gives you 4PCl3. Okay. What does it give you? 4PCl3. That means phosphorus trichloride. Again, we can take phosphorus again. Now mix it with thionyl chloride. This 8SOCl2. This one you see SOCl2. This is called as thionyl chloride. What do you get? Again, you get phosphorus trichloride, you get sulfur dioxide and disulfur dichloride. Now trick, everyone. Now it's time to see the trick, everybody. Take a look at it, okay? Take a look at it, everyone. Moving on. Now let's go for phosphorus pentachloride. Do you see something here? Cl2 and SO. Last time it was thionyl chloride, right? It was thionyl chloride, wasn't it? And this time it is sulfuryl chloride. So SO2Cl2. That's the difference. For phosphorus pentachloride and phosphorus trichloride, do you see the difference? 6Cl2, 10Cl2. 8SOCl2, 10SO2Cl2. Do you see the difference, everyone? Do you see the difference? Yes, Nandu, very good. No, not that. Due to apps, but yeah, that is also correct, Nandu. Yes. Do you see the difference, my dear students? Yes. See the difference? Got the trick? Got the trick? How to remember it? Sorry. Phosphorus trichloride and phosphorus pentachloride. Got it? Great. Amazing. So this is how you have to remember. I know it is a very dry and it is a very boring subject, but these are the tricks that are only going to make it a little more interesting. There is nothing much I can do. Even if I start dancing here right now, I will not be able to make it as interesting as your, organic or your physical chemistry is. So what can we do? And this is very important, like I said, a lot of questions do come. Now the chemical reaction, chemical reaction, take a look at it. Phosphorus trichloride, it reacts with water to give you orthophosphorus acid, Whenever you see PO3 here, do know that it will be orous, phosphorus, sulfurous, H3PO3, orthophosphorus acid. If it is H2SO3, it will be sulfurous acid, got it everyone? Yes, and it will give you hydrochloric acid. Now moving on, let's move on towards pentachloride. Pentachloride we have already seen, we have understood the tricks also, how to remember these two, right? How to remember these two, we have already understood this, correct? Now moving on here, see, this is how it looks, 4PCl5, see, pentachloride looks kind of like this, Now, chemical reaction of this is PCl5, you take phosphorus pentachloride, again water was there as well, right? What do you get? Phosphoryl oxychloride, and then you get orthophosphoric acid. See what I told you? PO3 phosphorus and PO4 phoric acid, orthophosphoric acid. Got it? Ma'am, whether metaphosphorus acid, we will talk about it, Singham, don't worry, that's very good, Uday. You should, the more you start, the more the more better it is. Sarthak, you feel like kindergarten, but it's fun. Oh, okay. Alright, moving on. Another one is PCl5. PCl5 you take, decompose it, heat it. What will you get? You will get trichloride and you will get chlorine. Alright? Very easy. See, very easy. Now, this is the most important part, my dear students. I was just telling you, right? This is the most important part of it. Ma'am, आप class 6 पढ़ाते थे, आप directly नहीं. No, Bimalandu, I actually teach 6 to 8, and in the platform of Vedantu, I also teach 9, 10th, and now I am teaching 11th and 12th. So basically, everything is covered from class 6 to 12. Everything is covered. And no, I did not directly jump. Before this, I was teaching 6 to 8, then I taught 9, 10th, and now I am here, Anyway, oxo acids of phosphorus. Now, very slowly, everybody, do I have your focus? Do I have your focus? Because I need you all to check out the structures very properly. Observe the structures very well, because from the structures, if you observe the structure, only then you are going to get the trick from here, how to remember all of these, Alright, let's do this. Yes, see, hypophosphorus acid. Take a look at this. Do you see the structure? You see the structure? Next, Next. Wait a second. There are too many slide this thing. Orthophosphorus acid. Do you see the structure? Do you see the structure, everyone? Moving on. Now what do you have? You have pyrophosphorus acids. Look at the structure. Yes? Are you able to find out anything common? Are you able to find out something common? Observe. What? If you find it out, please write it in the chat box. Let's see if anybody finds it. Moving on. Hypophosphoric acid. Take a look at it. Do you see similarities anywhere? Any similarities do you see? What? Singham, what do you see? Tell me, what do you see? What do you see? Shall I tell you? Chemical bonding se kitna relative hai, that's oh, okay. Do you see it? Yes, Orchid, I'll definitely tell my subject matter expert, I'll definitely tell my SME to make it black, sure. Hydrogen, that's the only common thing you found. Okay, let's do this. Yeah, let's do this. Let's do this. You know what is the common thing between in all the oxo acids of phosphorus? Okay, in all the oxo acids, you will find one thing. Most of them. There will be one thing that is common. That is, here will be one double bond O like this. Okay, and single bond OH. This is the common thing. Okay, this is the common thing. Do you see it, everyone? Do you see it now? Yes. One double bond with oxygen and one single bond with OH. Now take a look at it, everybody. Now see if I was right. Orthophosphorus acid, do you see? Yes. Now take a look at it. Pyrophosphorus acid, see? This is here, this is here, this is here, this is here. Do we see it? This is here. Do we see it? Now moving on again. Take a look at this. Take a look at this. Hypophosphoric acid, see? This. Do we see this? Yes? Yes, everybody? Yay? Got it? Orthophosphoric acid, see? This, again, similar? Yes? Similar? Yes? Pyrophosphoric acid? Okay. Alright. So now do you get it? Jayashree ma'am, please explain surface chemistry chapter concepts and problems. Sure, we will see. Okay, after this we will be doing DNF block, but we will see what can be done about it. Yes. So do we understand the trick, everybody? Now what I need you all to do is, I'll give you the notes. Join the Telegram channel. I'll give you the notes in the Telegram channel, and after that, everybody write all the oxo acids of phosphorus in one sheet. Okay, everyone listen to me carefully. Write all the oxo acids of phosphorus in one sheet, and then what you can do is you can make it by yourself. Make the structure by yourself, because you might get questions from this. It is very important. This is the most important part for your JEE and NEET. From oxo acids of phosphorus, there will be questions. There will be questions about the structure of oxo acids. So do you remember this, everyone? I need you all. Write all of them together. Yes, write all of them in one sheet, and then you will be able to count and write it down. How many double bonds are there? How many single bonds are there? Write that down. That is the way to practice this. Okay? Alright? Okay, everyone? Thank you so much, Abrar. Thank you so much. Okay? Is this clear? Shall I move on? Shall I move on to the oxygen family now? Shall I move on to the oxygen family? Is this clear? Come on, guys, everybody. Fast. Fast. Yes, you just have to remember some things and move on. Absolutely. Guys, can I have some thumbs up so that I can move on? I am not able to understand if you all are understanding or not. No interaction only. If that's the case, it's 9 o'clock, bro. I'm very hungry and I want to sleep. Shall I go home? Last line, what do I have to? Acha, I told you, no, same thing only. Double bond O and one single bond OH. Okay, write all the oxo acids of phosphorus in one sheet of paper. You will be able to easily identify the differences in the structure. But structure is very sorry. By looking at your chat, no, I'm saying whatever is coming in my, coming in front of my this thing. John, no problem. John just said kaan pakad ke sorry, and I said that it is instead of saying is very important, I said is very sorry. Okay, once again, everybody, oxo acids of phosphorus, the structures are really important. Please do write it down in one single page. Write all of them down together so you can easily identify the differences. Alright, moving on to oxygen family. Now, how are we going to remember oxygen family? Just say this together. This is like a mantra, okay? OS tepo, OS tepo, OS tepo, OS tepo. Just say this again and again. I think you will be able to understand it, okay? It's very easy. OS tepo, OS tepo, okay? That's it, you have to write. Now, everybody, I told you about magic numbers. Can you try it again here? 2, 8, 8, 16, 16, 32. Try it. Try and find out, everyone. I'm going to make you practice right away only. Everybody, please help me out with it. Yes, Sunil, Uday, John, everyone, come on. Singham you have, I know. Glory, peroxide. This thing. Wait. I'll show you. I'll show you where is this. wait up. When we are doing when we are doing the next part, I'll show you. Now it'll be tougher to find it. I want to show it to you from the structure only. So I'll show it to you later. Don't worry. Okay. Yes. How? Shagun. OSA Tepo. Yeah. Now find out. I gave you the magic numbers, no? 2, 8, 8, 16, 16, 32. Find it out. Does it match? Does it match, everyone? It matches? Yes? Ha! Great! So will you all now remember the magic numbers? Anytime anybody asks you, ma'am, what is the atomic number of this element? Just know the group and find it out, because magic numbers are at your fingertips. 2, 8, 8, 16, 16, 32. That's it. Now your JEE and NEET is also going to be easy, because if there is anything related to periodic table, you know how to find out. Okay? That's it. Moving on. In this case also, what do we see is 288. Is there a mistake? No, perfect. No, it is. Singam, perfect, right? Clear. Okay. All right. Now we see that in this case also, the first two elements are non-metals, then there are metalloids, and then there is polonium, which is, yes, the polonium, that was radioactive metal. Okay, the polonium is radioactive metal. All right, moving on, everyone. क्या बात कर रहे हो? Oi, everybody, don't start gossiping among yourselves. Please focus here. We are not teaching you, I'm not teaching you anymore for 6 to 8 here, okay? I understand if you are in 6 to 8 in your lower grades, you want to have fun, absolutely great. But right now, I need you all to focus here. Don't start gossiping there, everybody. Yes, radioactive polonium. All right, everybody. Now, let's take a look at the oxidation states. My dear students, look at the table. What are the things that you see? What are the things that you see here? Do you see something that oxygen does not have this positive +6 state? Yes, oxygen does not have this positive +6 state. Okay, let's come back here. What is the general electronic configuration? The general electronic configuration is NS2NP4, right? So that means that either you can take out these 4, okay, either you can take out these 4, or you can take out all the 6, or what you can do is you can give 2 here so that they can fulfill their octet rule. Achha, one more question that I forgot, everybody. Did you know that the nitrogen family is more stable than the oxygen family? Why? Why is the nitrogen family more stable than the oxygen family? I'm pretty sure that everybody who are here in this session do know the answer. Why? Because nitrogen family has NS2NP3. That means it is NS2NP3. NP3, it is half filled, and full filled are always more stable. Is that right? But here it is not like that. Okay, here it is not like this. So now tell me something, everyone. Do we understand the general electronic configuration NS2NP4, right? From here, now take a look at it. Oxygen. Do you think it will be easier for oxygen to give away all the 6 electrons? Will it be possible? Not possible. Not possible. Oxygen will not be able to show the +6 oxidation state. However, that ideally it should be, right? Ideally it should be from 6 to 2 or 6 to, this is what these are the oxidation state. But you see that oxygen is not able to show you positive oxidation state, +6 positive. Something just happens, yes. Sorry, +6 oxidation state is not being shown by oxygen, right? It can only show you -2, -1, 1 and 2. Okay. But now, do you see that while you are going down in the group, the +6 oxidation state increases, also +2 increases. Do you see? Most of them are able to show +2. Most of them are able to show +2. Why? When do you get +2 oxidation state, my dear student? When will you get +2 oxidation state? Everybody, when will you get +2 oxidation state? Orchid, very good. Enough. I know. Why are they showing +2 oxidation state? Come on. I need to see. Singam, I'll give you that answer after some time. But right now, please focus on what I am asking. Huh? +2 oxidation state. when 2 electrons will be gained. Then it will be plus 2 or minus 2. Noble gas configuration. You guys are just throwing things like this. Absence of d orbital. 3 to 4 things you have learned. Ma'am, inert pair effect, ma'am. Noble gas configuration, ma'am. And ma'am, absence of d orbital. These 3, then you are like, ma'am, P block is done, ma'am. That's it. These 3 you need to know, These 3 you need to know, That's it. That's all that is important, Think, no, bacha. Think, everybody. Think. Come on, think. You know this. It's a very easy question. Bigger size, they don't really care about the electrons. They are like, hey, you know what, take it and go. Just take it and go. And that is why there can be plus 2 oxidation state. Yes, these are bigger size, you know. And what are they going to do? Their attitude will be just take it and go. I don't really care. Take it and go. Right? And when it becomes take it and go, they're like, sure, we will show positive oxidation state now. Got it? Yes. RD for half filled. Now I do not know what you are asking about. Half filled was for nitrogen family. Bhai. Tamil accent is really amazing. But I'm not Tamil. Anyway. Properties of hydride. In the last section, nitrogen family, what was it? It was NH3, PH3, BiH3. But here the hydrides are H2O, H2S, H2SE, H2TE. So OS say te. Okay, OS say te. Say te po, right? Po is not here. Only OS say te. Yes? Got it, everybody? Now here the acidic character of the hydrides, we see that it increases down the group. Why? Less bond enthalpy. The bonds can be broken very easily, isn't it? Which is what I told you. So if you have understood it for the nitrogen family, then you can understand for this also. Bond angle is bigger. No, bond is bigger. You can easily break it. You need lesser energy. Yes, see, less bond enthalpy for the bond dissociation. That is why it increases down the group. Where reducing character also increases down the group, my dear student. Reducing character also increases down the group, whereas H2O is non-reducing. Okay, H2O is non-reducing. Okay, now let's talk about dioxygens. Yes, absolutely right, Uday. Absolutely right. Yeah, absolutely clear. No, okay. Now we come to preparation of dioxygen. So we take potassium chloride, heat it. What will you get? KCl, oxygen. Again, this is also something that you have read in your younger classes, you know. In your lower grades, you have read it. Then we have lead. So only two things, okay. Only 2 things you have to learn. That is lead and potassium chloride. This will form lead oxide and oxygen. Okay? Alright, then what do you have? You have hydrogen peroxide. Hydrogen peroxide, what does it form? This is also very easy. You heat it, you get water and you get oxygen gas. Are you writing it down, everyone? Are you writing it down? Orchid, I will need you to just rewind a little bit and watch it. Bacha, please, will you mind? I have already taught nitrogen family and it took me 1 hour already. Yes? Please, can you do this for me? That will be a big, huge favor for me. Please watch it, okay? I've taught it. Already I've taught it. It's there. Moving on. Now, reaction with metal. Hey, this is something that I don't even have to teach you. You all know this. How do metals react with oxygen? Metals react with oxygen and forms a metal oxide. That's it. You have been learning about this since class 7, right? Class 7, class 8, you know about this. How does oxygen react with a non-metal? Again, it reacts with a non-metal and forms non-metallic oxide. See, sulfur dioxide, magnesium oxide. Magnesium burns with oxygen and gives you a dazzling white flame and all of that you have read, no? That's exactly what it is. Do I really need to teach you? Do I really even have to teach you? Huh? You all are probably thinking that, ma'am, this all comes in JEE. Then to definitely done, ma'am. We will clear it, right? Everybody, you will clear it, no? We will save your this thing. Yeah, this is 12th chapter. This is 12th chapter. Yes. Now, reaction with compounds. Carbon disulfide, if you take, if that reacts with oxygen, it will form carbon dioxide and sulfur dioxide. Again, easy. Carbon disulfide, very easy. See, my dear student, you know already. You already know this. carbon disulfide, dioxide, sulfide, see here. This is also easy, Shagun. Carbon disulfide, carbon dioxide, sulfur is here, so you are getting this also. Yes, you are getting this also. Glory Angel, I have not read, I have not reached there. Wait. Imagine this to be a movie. Yes, when you go watch a movie, you don't forward it and go to the end of the story, right? Yes. So right now, focus here. I'll tell you about everything. Don't worry. Okay. Now we come to zinc sulfide. See, zinc sulfide, what will it give you? Zinc oxide and sulfur dioxide. That's it. Yes, that's it. Easy. Now we come to something important. Ozone. What is ozone? What is ozone, my dear student? Ozone is basically an allotropic form of oxygen. Yes, oxygen normally exists as O2, but in here you get it as O3, right? What you know these properties, right? It protects from UV rays and all of this. You have learnt it in lower grades. Laboratory preparation. Okay, once again, everybody, take a look at it. Just take a look at it. Do I even have to teach you? You take oxygen, it gives you ozone. Take oxygen, electric discharge, it gives you ozone. You just had to heat it. That's it. But if you take ozone is also highly unstable, my dear students, okay? So the moment ozone tries to, come down, what happens is oxygen and you get a single oxygen, okay? This is dioxygen, O2. And there is one single oxygen which is called as nascent, okay? Nascent means initial stage, like, let's say that today if I want to start a company, if I start a company right now, okay? Right now, a thought of a company came in my head, and let's say that from tomorrow I start working on the company. The moment people ask like, hey, what's your company? I'll be like, my company is working, but right now it's at nascent stage. Nascent stage means very initial stage. I've just started it right now. That's called as nascent stage, okay? Understood? Yes? No, nascent oxygen does not exist. That is also very reactive, okay? That is also very reactive. And that is why ozone is a strong oxidizing agent. See? Ozone is a strong oxidizing agent. It is not, it cannot stay. It's very unstable. It's very unstable, okay? Alright. Got it, everybody? Yes? Ozone was a part of, I know, ozone is a part of environmental science anyway. Now let's talk about the chemical reaction. Sanjay, what, how, bacha? What is it that you are asking? Which one did you not understand? Which one did you not understand, bacha? This, you didn't understand ozone. I said that ozone, when it comes down above the atmosphere, right, like at the top, it is stable. It's there. It's protecting us from UV rays and everything. But if it tries to come down, then it becomes nascent. You didn't understand. So ozone breaks down, okay? Ozone breaks down into oxygen, dioxygen and one single oxygen. Now this is highly unstable. This is highly unstable, okay? Yes. And because this is highly unstable, it tries to mingle with someone. It's like, no, let me just be with someone. So what will it do? When it is trying to mingle with someone, what is it doing? It is a strong oxidizing agent. Are you understanding now? The hidden silence, Sanjaya, did you understand this now? Why is this happening? Now I don't see any response. Oh yes, see, common sense, easy. Anyway, chemical reactions. Thank you. Okay, now. Glory Angel, focus. Hindi में समझा दूंगी. But if I start teaching in Hindi here also, no, I think this will not be the right place for me to speak in Hindi here. Like I said, this is an official English channel for JEE and NEET. My dear student, if you really want to learn in Hindi, I would request you all that please go to NEET Made Easy, baby. There Wasim sir is teaching, or you have Vedantu JEE channel as well. Please go there. I'm so sorry. I will not be able to take Hindi in this channel, okay? Yeah, I'm so sorry, Anuj. Anyway. Now, how can we, chemical reactions of ozone. Let's talk about some of the chemical reactions of ozone. Okay, so you have lead sulfide. Lead sulfide reacts with CO3. O3 means ozone. Please do remember it, okay? O2 dioxygen, O3 ozone, okay? Then what will you get? You will get lead sulfate and oxygen. Obviously. Most of the time you will see that oxygen is coming out. Most of the time you will see that in the reactions of ozone, you will see that oxygen is coming out. In here also you are getting to see the same thing. See, iodide, water, ozone, what are you getting? 2OH minus, iodine and oxygen. See, iodine and oxygen. Getting it? Are we understanding? Everyone, I hope that you are still writing it. No need, we don't have to balance it, no? You just have to remember the reaction. You have to remember the reaction. Balancing and all that you can do later. Now, nitric oxide, again ozone, what will you get? Nitrogen dioxide and oxygen. Oh, everywhere did you see oxygen, oxygen, oxygen? That was the common, that was the trick. Yes, everywhere you got oxygen, oxygen, oxygen. Okay? Moving on. Now, sulfur allotropic forms. Sulfur also has allotropic forms. Okay? What are those? There is a rhombic sulfur and there is monoclinic sulfur. Which one is more stable? Does anybody know about this? Which one is more stable? Which one is more stable? Yes. Come on. Very good. The hidden silence, you have already studied about everything and you have come here, huh? Is that so what it is? Rhombic is more stable. Absolutely right. Rhombic is more stable. So rhombic is called as alpha sulfur and monoclinic is called as beta sulfur. Okay. Alright. Now these two are also interchangeable, by the way. Huh? These two are also interchangeable. See. These two are also interchangeable. Rhombic, heat it, monoclinic, monoclinic, cool it, rhombic. Yes. These two are interchangeable. Okay. Also there is a, this is transition temperature. Okay. This is important. Transition temperature 369 Kelvin. I am not kidding. There has been questions regarding this transition temperature in JEE and NEET. Can somebody tell me what do we mean by this transition temperature? Can somebody tell me what do we mean by this transition temperature, everyone? Hidden silence, that's just a name. Don't worry about it. Don't worry about it. Yes, please tell me what do we mean by transition temperature? Any idea here? Everybody. Please try to answer it. I will need to drink some water, okay? I'll need to drink some water. Huh? Monoclinic, you mean? Very good. Spinelli, 7x army, absolutely right. At 369 Kelvin, that is the transition temperature. Both the monoclinic and rhombic, both of the sulfurs are present. Both of them are present. Yes, no, Anuj, not 50% liquid, 50% solid, none of that. Both of them are present. Okay, both of them are present. Shagun? Transition temperature, both of them are present. That's what you're going to say, okay? Now moving on, let's take a look at the structures also. So there is a crown form and there is a chair form, right? There is a crown form, there is a chair form. That and all you can see and you will be able to understand it easily, right? When we are again going to do it in elaborate way, at that time we will learn it. Let's learn the reactions now. That's very important, okay? So sulfur dioxide. How do we prepare sulfur dioxide? How do we prepare sulfur dioxide? Okay, this, do I have to teach you? Look at this. Look at this. S plus O2, SO2. Do I have to teach you this? Nah. Orchid, I would require you, just Google that, yeah. Just Google that. I think you'll be able to understand that better. Google that, Orchid. Google that. Whatever you're writing, copy, paste, Google it. And then come and tell me the answer. That is easy peasy, biryani is tasty. I want you to find it out by yourself. Come on. Not this one, right? Great. Amazing. Moving on. Or you can take sulfite, H plus, water and sulfur dioxide. That is also fine. That is also fine. Nothing much to learn here. Nothing much to learn here. And then finally you have the industrial method, which is what do you do? By roasting of sulfide ore. Okay, what do? You roast the sulfide ore to get it. So what do? You take iron disulfate or iron pyrite, oxygen and ferric oxide and sulfur dioxide. Okay. Ferric oxide and sulfur dioxide. I think most of us know about this also, right? Most of us know about this also, don't we? We know this, right? Ore, How to get it from the ores? We have read it somewhere. Why do I feel like? No, you must not have. No, you must not have. Okay. Believer, thank you so much. Thank you so much. No, but I think Orchid will come back. Orchid, you will come. That's your assignment, my dear student. That is your own assignment. You come back and tell me. Quite different. No, you must not have seen it. I'm sorry. That was my bad. Okay. So iron disulfate or iron pyrite if you take, and then if you add oxygen to it, what will you get? You are getting ferric oxide. Obviously, yes, there is iron, there is oxygen, so obviously ferric oxide, right? Common sense. And you are getting sulfur dioxide as well. Okay. Moving on to sulfur dioxide's reactions, chemical reactions. This also I don't think I have to teach you. Sulfur dioxide plus chlorine, what are you getting? You are getting sulfuride chloride. Rhombic sulfur is an example of orthorhombic crystal system. Thank you so much. See, now do you understand the difference? Now do you understand the difference, Orchid? Now I'm sure that you will remember it for your life. The fact that you asked me and the fact that you searched it and you came back on your own, now you will get it. Yes, it's an example of orthorhombic crystal system. Great. Alright, moving on. Now what are we going to do? We are going to take again sulfur dioxide, oxygen. What do we get? Sulfur trioxide. Oh God, such easy examples, such easy reactions. Yes. Now, you have sulfur dioxide, lead sulfate. Come on. I mean, the moment you see these reactions, you're like, oh, I just had to balance it. That's it. Right? Doesn't it look like this? O2, O2, O4, S, S, PB, PB. That's it. I mean, what do I have to teach you? Vanadium oxide, bacha, vanadium oxide. Remember that Sachin Tendulkar, very crazy man, the 3D series, Scandinium, Titanium, Vanadium, vanadium oxide. Okay, vanadium pentaoxide. Yes. Okay. Now, oxo acids of sulfur. In here also, can we take a look at the structures again? I'll tell you the trick how to remember all of it. Can we see the structures, everyone? Take a look at it. What do you see? I need you all to observe. I'm not going to tell you the answer this time. You know the oxo acids of phosphorus now, right? Now tell me oxo acids of sulfur. Sulfurous acid done. See? Sulfuric acid. Take a look at it. Raghavan, I'm so sorry, I do not know the Tamil language, bacha. I only know English. Yes, thiosulfuric acid. See. You will see. Peroxo monosulfuric acid. Yes. See. Are you understanding? Peroxo disulfuric acid. See. So now did you understand? Now do you understand? Did you see something? Thank you, Shagun. Thank you so much. Glory, you were almost there. Okay, I'll tell you. There are these three things. See? Double bond O, and single OH. Okay? This is the common one. Again, I will need you to do the same thing, please. Okay, bacha log, my dearest students, my dearest Enlite students, please understand that in this case, the more you practice, the more you write down your notes, the more easier it will be for you to understand. I'm trying to make it fun. I'm trying to make it easy. I'm giving you the tips and tricks and everything, but you will have to do the hard work also a little bit. So promise me by this weekend, okay? Promise me by this weekend, by tomorrow, Sunday. Tomorrow is Sunday. Watch this session again and do the assignment that I have told you. Write all the oxo acids, okay? Yes, write all the oxo acids in a piece of paper and make sure that you identify the differences in the structures. Will you please do it? Because it's very important. Trust me, I'm not kidding that a lot of questions do come from this. Playing like a boy, please tell me what's your doubt. Don't just ma'am doubt. Yes, please tell me what's your doubt. Yes. Now, you were asking what was peroxo disulfuric acid. This is the peroxo. This is the peroxo. My dear student, this is the peroxo. Glory, you were asking, no? See, I've answered your doubt. This is your peroxo, okay? Understood? Moving on. Yes, so in this case, what is it that we have understood? For oxo acids of sulfur, usually, generally, what is it? Generally, you have a S here, you have double bond O, and OH, okay? This is the common one. Now you have to write down and you have to work hard, okay? Alright, yes, okay? I love family. I'm telling you all the common things, no? I'm telling you all the common things. Sambit Rai, I just told you V2O5 is vanadium pentaoxide. Vanadium pentaoxide, I've told you already that. You're not listening. You're not listening. Okay. So oxo acids of sulfur, you all will be able to do it. You all will be able to do it, right? I'm skipping. I'll give you the notes also. I'll give you the notes so that you all get to see it and properly learn it. Now we go to sulfuric acid. Okay, so sulfuric acid, is there anyone who does not know? You got your doubt clear? Thank you so much, playing like a boy. Yeah. Preparation. How do we prepare sulfuric acid? So this is your contact process, my dear student. Again, very easy. Sulfur dioxide you have to take and you have to make it reach to sulfuric acid. So what are we going to do? Sulfur dioxide, sulfur trioxide. Sulfur trioxide, then what are you doing? Yes? Hey. Acha. Sulfur trioxide. Okay, no, this is right, yeah. Sulfur trioxide, add sulfuric acid, you are going to get oleum. Now in oleum, add water, you are going to get sulfuric acid. Yes, understood? H2SO4, ha. This is your contact process, okay? This is your contact process, got it? Now let's talk about the chemical reaction. Strong acidic character, what do we see? Yes? Oh, that sound. What sound is that? This sound? I think it's the AC. I think it's the AC. Modern man, I'm going with you. I have just started recently from the last month. And if you are with me, I think you'll be able to do it. I think you'll be able to do it, okay? Yeah. Shagun, it's not that confusing. Not that confusing. Just have to remember two things here. See? Sulfur dioxide, oxygen, sulfur trioxide. Sulfur trioxide, sulfuric acid, you get oleum. With oleum, add water, you get sulfuric acid, okay? That's it. I know it's just a little bit confusing. No problem. Anyway, strong acidic character that we all know, right? Now, sulfuric acid with water, you will get what? See? The ions. This is where the ions come into picture. Yes? And these are the ions that again we have learnt it in our lower grades, isn't it? Yes, we have learnt it in our lower grades. So we all know that this is a very, very, very strong acid, isn't it? Yes. Now moving on, again see, if you take hydrogen sulfate and mix it with water, you are going to get this again. You are again going to get the hydronium ion. Yes. You are in Mohit sir's class, carbonyl compound. Very good. No problem. You can study from here or you can study from it. Same thing. Both of us are in Vedantu only. Yes. No problem. More acidic. Absolutely right. Okay. Absolutely right. Yes. Do we understand this? Yes, when the class is ending, the moment we finish it, we are almost there. It is also diabetic. So you guys have already learnt it, no then? You guys have already learnt everything. Very good. Okay, strong oxidizing agent, we also know this, right? Chemical reaction, strong oxidizing agent. So you take copper. Then what do you take? Concentrated sulfuric acid, you will get copper sulfate. This is something that you know, right? This is something that you know already. You have read about these in your lower grades also, right? Then what do you have? You take some sulfur and you take concentrated sulfuric acid. You will get sulfur dioxide and water. Okay? Alright everybody. Dehydrating agent. Yes, it is also a dehydrating agent. Charring of sugar. This is important. Take a look at it. See, sugar, concentrated sulfuric acid. You will get carbon and water. Yes. Now finally we are almost at the end of the chapter. Okay, tell me something. Do you want me to take it right now or is your brain saturated and you want me to stop right now? Whatever you tell me. If you want me to take another session, then I can take another session of this, or if you want me to complete it right now, I can complete it right now as well. You tell me, what do you want? What do you want? Now? Everybody now? Carbon is already done, Uday. Carbon and boron we are done. Now in 15 minutes. Harini, I am giving you the tips and tricks also. Break for 5 minutes, a small headache. I can't understand. Everybody vote. What do you want me to do? Take right now? Chalo, let's do one thing. It's already 9:36. 15 minutes, let's complete it. Chalo. Why take one more session? No, let's complete it. Let's complete it, yes. So, electronic configuration of fluorine. Everybody, once again, everyone, yes, let's take the halogens also. We all know that fluorine is the dawn, right? Fluorine is the dawn of this family, isn't it? The most dawn of the whole periodic table, in fact. The whole periodic table, fluorine is the dawn of this. Now here the general electronic configuration, very good, thank you Udaygiri, it is NS2NP5, isn't it? Yes, then you have fluorine, chlorine, bromine, iodine, astatine. Okay, so how do we remember this? I think I wrote it somewhere but I forgot. Okay, it is for cool breeze I8, okay, for cool breeze I8, okay, just write this, you will be able to understand. Yes, Orchid, that's why I said, no, it's the dawn. In the whole periodic table, it is the dawn, right? It is the most electronegative element, right? Udaygiri, that's for Hindi, no? In this channel, I have to teach in English, that's why, okay? Yes, anyway, moving on, everybody. Yes, now here also we see that the first two elements, these are gas. Yes, bromine is liquid, yes, and you have iodine and astatine which are solid. Do you know that bromine is the only non-metal that is in liquid form? Yes, bromine is the only non-metal that is in liquid form, okay. Normally, most of the non-metals are found in gaseous state and solid state, but bromine is the only one that is found in liquid form, okay. Alright, astatine is obviously radioactive. Yes, astatine is obviously radioactive. Yes, moving on from here, let's talk about chlorine, okay. So obviously we will again talk about preparation of chlorine. Let's do it fast. Everybody focus up. All the doubts and everything I'll take it later. Now focus up here, okay. How can we prepare it? We will take manganese dioxide and we will take concentrated hydrochloric acid, and what will we get? We will get manganese chloride and we will get chlorine plus water, obviously, right? Obviously we will get some water. Sanskar Pava, you are spamming, sweetheart. Don't spam, no? Focus up. Yes, then we take potassium permanganate and we will add some, and we will take some concentrated hydrochloric acid. What we will get? We will get potassium chloride. MnCl2, we will get some chlorine and we will get some water as well. Will you take class 12 Harini? My dearest student Harini, this is like after teaching the whole Ramayana, now you are asking me, Ma'am, Sita was a boy or a girl? Sunil? Harini. What is this? I'm teaching you halogens, P block halogens, group 17, that is class 12 P block. Anyway, I think it's about to be 10 and everybody is like, ma'am, done. I think you are hungry, that's why maybe you're asking me these questions. Anyway, let's talk about the industrial preparation of chlorine, that is decons process. Anything and whatever we need to take is right here. Hydrochloric acid, oxygen, chlorine and water. Easy everybody, right? Then we have electrolytic process. Oh my god. Okay, this is something that you have read. You take brine, water, electrolysis and you get chlorine. Right? This is something that you have already read, isn't it? See, this feels like you have already learnt about all of this. The modern man, please watch the whole session, sweetheart. I have actually given you some tips and tricks as well that will help you remember all of these. And yes, there is no other way, but you have to mug up all of these. So if you practice, you will be able to understand, you will be able to remember all of these. Yeah, please help me with it, okay? Reaction with NH3. Chlorine, how does it react with NH3? If you take excess amount of NH3, yes, Sunil, ask me. Then what will you get? You will get ammonium chloride and nitrogen gas. Yes, now if you take excess amount of chlorine, not NH3. If you take excess amount of chlorine, what will you get? You will get nitrogen trichloride. Decons process also explained. Very easy, no, bacha, decons process. All you had to take was hydrochloric acid, add oxygen. Yes, add oxygen. You take copper chloride as well as a catalyst, okay? Heat it, you will get chlorine and water. That's it, okay? That's it, decons process. Okay. Okay, moving on everybody. Yes. So do we understand? If you take ammonia excess amount, you will get ammonium chloride. If you take chlorine in excess amount, then you will get what? You will get nitrogen trichloride. Okay, this you have to remember. How to join AFMC? Exam, that's it. Anyway, reaction with NaOH. Okay, this is something that I again don't have to teach you, because if you take sodium hydroxide and mix it with chlorine, what is it that you can expect? You will get salt, baba. You will get common salt, sodium chloride, obviously, right? You will get sodium chloride, you will get sodium hypochlorite and some water. Okay, sodium chloride, sodium hypochlorite and water. All right, now if I take sodium hydroxide hot and concentrated, yes, and I mix it with chlorine, then what will I get? I will get more NaCl. Sodium chlorate, I will get hypochlorite and chlorate here. Okay, this is sodium chlorate and you will get water. Does P block has any use for GE? I am just passing the time, you think, right at 10 o'clock. Don't you think that I would be happier to eat my dinner by 8:30 and sleep by 9 o'clock? If it was not so important, why will I be teaching you the hidden silence? Huh? At this time, why would I just pass my time if it was not that important? Anyway, reaction with dry slaked lime. Okay, take a look at it. Slaked lime, if we take and add chlorine, what will you get? Calcium hypochlorite and calcium chloride. Guys, I am not gonna write all of these things. Yes, that's why the whole notes are here. I'll give it to you. Okay, I will give it to you. All right. Why are we not using iodine for all elements? Why will we use iodine for all elements? Why will we do that? From where are this question coming? Yeah, you guys are asking me any question. I think I should just finish it quickly and go. Why don't we use fluorine? Okay, now see, you wanna ask me anything and everything under the sun? That's going to be tough now. Yeah, this is like, come on guys. Anyway, calcium hypochlorite is basically something that is also present in your bleaching powder. Okay, it is present in bleaching powder. All right. Yes, everybody got it? Yes, Glory. Now, hydrogen chloride. Okay, it is colorless and pungent smelling gas. Okay, it causes solution. It is also, what is it? Aqueous solution is called as hydrochloric acid, HCl basically, right? Preparation of hydrogen chloride. What can we do? Take common salt. Take common salt, take some concentrated sulfuric acid, you will get sodium bisulfate and hydrochloric acid. Very easy, right? Next thing what we can do is, we are going to take sodium bisulfate again, yes, and then we are going to add some sodium chloride to it. What will we get? We will get sodium sulfate and hydrochloric acid. That's it. Again, we are going to talk about the acidic nature here as well. See, what are we going to do? Water and hydrochloric acid, we get the hydronium ion and Cl minus, and we see that this is also a strong acid. We can see the Ka power, right? And we can understand that this is also a strong acid. Reaction with metal. Why are we quickly changing the slides? Because it's all about to be 10 and I am taking class since 8 p.m. The modern man, I think you are here only right now and I am anyway going to give you the notes, right? Sadayandi Sundaraj, what happened to Wasim sir? Nothing. He is teaching you organic and physical chemistry, and because he is also a part of other channels, that's why I am here to only help him. Okay, he will be definitely taking care of your organic and your physical chemistry, and I am taking care of inorganic. Is that okay, Sundaraj? Okay, all right now. Yes, yeah, we will finish noble gases also. Everything right now only. Reaction with metal. Reaction with metal, everybody. Zinc will react with hydrochloric acid and what will it give you? Zinc chloride. This is something that you already know, right? If you have please. Okay, Glory, that you will have to do, bacha. That you will have to do. I've told you the structures, no? Once you write down all the structures in one page, you will actually be able to understand why the names are there. Okay? Why the names are there, you will be able to understand. Anyway, guys, reaction with NH3. See, ammonia will react with hydrochloric acid and it will give you ammonium chloride, which will be white fumes. Okay, it will be white fumes. All right. Yes, Moving on everybody. Structures of oxo acids of chlorine. Okay, this is easy. There are not too many, so I think you can understand this. This also you will have to learn. There is nothing that we can do about it. We have to learn it, okay. There is chloric acid, hypochlorous acid and chlorous acid, okay. Alright everybody, and there is also perchloric acid. So this you will have to learn. I give you the notes. Don't worry about it. Just learn from that, okay. Learn from that, okay. Study and only in inorganic chemistry the catalyst we use to make the reactant molecule to product and the catalyst. Yes, study and only. I do not know. Modern man, you have to be a part of this channel, bacha. Now you are asking me all the other things. Fumes are smoke. Effervescence are like bubbles, small bubbles. That's the difference. Crystalline, that's the difference. Got it? Yes? Okay. Interhalogen compounds. Okay, this is interesting. Sarthak, just explain. No, you guys are not focusing anymore, huh? See here. NH3 ammonia reacts with hydrochloric acid, forms ammonium chloride, which are basically white fumes, okay? Alright, now moving on everybody, focus up, let's finish quickly, Yes, Udayagiri, we're going to talk about why are you're going to understand now, yes, why? Okay, who is the head of the family? Hidden silence, who is the head of the family in case of this? For halogens, who is the head of the family? Fluorine. Fluorine is the most electronegative, right? So what will fluorine do? Fluorine will also try to form compounds with other halogens. Yes, that is why. So there is one, see, take a look at it. The interhalogen compounds, as you can see, one of them will be of larger size and this is going to be lesser electronegative, but this one is going to be of smaller size and more electronegative, and most of them are formed by fluorine. Take a look at it, see, take a look at it everyone, see, 2ClF, 2ClF3, okay, yes, 2BrF3, yes, then what do you have, see, 2BrF5, it's all fluorine. These are all done by fluorine. Yes, these are all done by fluorine, right? So what? The hidden silence. There are bonds that you have to understand. Yes. So what? If they're all... Absolutely. Now do you see the common thing here? Why this is happening? Yes, why this is happening? Okay. Yes, also the N can be only 1, 3, 5, 7. Make a note of this, okay? Make a note of this. N can be 1, 3, 5, 7. Alright? Okay, everybody? Yes, moving on. We are going to move on from here. I think I'll have to give you a little bit more time for this halogen compounds. Maybe later. Maybe we will take another session of P block, okay? We will take another session of P block and we will clarify all the doubts that you have. Does that make sense, everyone? Because I feel like everybody is done and mine has switched off. So I'm just going to complete it right now and then we will come back to it later. Okay. I really do feel like that. Anyway, so these are the types of compounds that you can see. Okay. And these are the shapes that you will see. For CLF or BRF, you will get to see a linear shape. For CLF3 or BRF3, you will get a T shape. How is it T shape? Only look at this part. Not at the lone pairs, okay? Not at the lone pairs. Take a look at this part. Does it look like a T? It does look like a T, right? Yes? It does look like a T, isn't it? Then, CLF5, BRF5, square pyramidal. Now, what are you going to see? You are going to see only this part. You are going to only see this part. How will it be? It will be like this. It will be like this. Isn't it? Not 5, actually. Not 5, like this. See, it's going to be like this. So this is also like a pyramid only, right? Yeah. Moving on. Then you have pentagonal bipyramid for IF7, okay? T-shaped, crystalline T-shaped, okay? T-shaped. We're going to write it as T-shaped. And finally, noble gases. Okay, noble gases is what? Fully filled octet, NS2, NP6. Okay, NS2, NP6. That's the general electronic configuration and all of them are gas. Okay, all of them are gases. Alright, everybody. Moving on, how do we prepare? See, xenon and fluorine compounds preparation. If you take xenon in axis and then if you heat it, you will get xenon difluoride. 1:5 ratio, you will get xenon tetrafluoride. 1:20 ratio, you will get xenon hexafluoride, but in all of them you have to heat, okay? You have to heat them, okay? You have to heat them. And they also have structures like this. Oh, okay, if it is xenon difluoride XeF2C, you are only going to see this part. Linear, right? This is linear, yes? Then you have square planar, as you can see, yes? Then you have here distorted octahedral. Can you see this also? Can you see this also? Yes, absolutely. Yes, Uday, you are right, okay? How can this get... We saw no. Hidden silence, you didn't pay attention. All of this you have to heat, my dear student. You have to heat them. You have to heat them. You have to give a lot of energy here. Not just like it. Obviously, in their own state, they are very comfortable and they are not going to form any bond. But you are heating them here. You're making them uncomfortable here, right? Only then they are forming. Yes, high temperature. That's it. Okay. All right. Xenon oxygen. Preparation by hydrolysis. What are we doing? We are taking xenon hexafluoride, water. We will get xenon trioxide. Okay. Then if we take xenon tetrafluoride and if we mix it with water, what are we getting? We are getting xenon trioxide. Okay. All right, everybody. Moving on. I'm quickly just going through. Okay. I'm just quickly going through. I don't think there is enough time and your mind has switched off. Noble gases will not comply. Singham, again, one more time. Sweetheart, like I just told you. You have to heat them. You have to heat them. Okay? Yes, you have to heat them. Abhi, why xenon can't? Guys, what happened? All your basics have like just gone, huh? All the basics have gone. Yes? Abhi is asking why xenon can't bond among itself like Xc2. You tell me. I don't even want to answer that. You tell me. Abhi, okay, Singham, Kaushal, you tell me. Uday, you tell me. Come on, everybody. Why xenon can't bond among itself like Xc2? I don't want to answer that. I know that you know this. Come on. This is a common sense question. Yes. Anyway, XeO4, because it's a no. Absolutely. Why will two of them stay together? It's a noble gas. It is fine. It's chilling by itself. Only if you make it too uncomfortable, if you give it really high temperature or high pressure, maybe then it will react. Okay? Maybe then it will react. Nowhere else. It will not react. Got it? Yes. Okay. Anyway. Absolutely Harini, because of its completely filled octet. Anyway, xenon hexafluoride. Yes, mixed with water. What are you getting? Xenon oxytetrafluoride and HF, alright, and HF, alright. Moving on, xenon oxygen, there are a lot of them. We're just quickly finishing it. Xenon hexafluoride, if you take, again mix it in water, what will you get? You will get xenon dioxydifluoride, okay. Xenon dioxydifluoride. Now this one has a seesaw structure, okay. This one has a seesaw structure. Guys, I think we really have to read about this, right? We will have to read about this. Again, all of these structures, how are they forming? Hybridization. Why are they forming? Why are noble gases forming compounds? All of these we will have to talk about it again. So how about, let me take another session. Let's complete a little bit more of these things, okay? We will start with DNF, this thing. Lashmi, how to find boiling and melting point? Let's talk about this later, okay? Please explain the nature of pi bond. Okay, Glory, like I just said, I think it's about to be 10 o'clock. There is no point in delaying it further. Even I am feeling a little weak and hungry and everything, okay? Alright, how about we take another session? We take another session a little early probably. Let's take it a little bit early, okay? So that we can... Any homework? No homework. I'm not going to give you any homework. The only homework is Sunday ko... All you need to do is write down all the oxo acids of all the oxo acids. Just make sure that you write every oxo acid. That's all that I would ask, okay? That's all that I would ask you. Yes. You speak only English. No, I can speak English, I can speak Hindi, I can speak Bengali, I can speak Assamese. But in this channel, I'm going to speak only English. Can I use Vedantu after class notes as my short notes because I have so much? No problem. Yes, no problem. Definitely, okay? Yes, definitely. Yes, hidden silence. We will talk about it very well, okay? Don't worry about it. I will take you through it. But anyway, do you understand the first two parts? Yes, nitrogen family and the oxygen family. Did you understand? Did you understand those two? We will talk about the halogen and the noble gases later. Is that okay? Is that okay? Thank you, NEET Motivation. Thank you so much. Next class will be on Monday we will have the next class. Why these are very complicated? What to do? This is how life is. Please tell me, guys. Did we understand that oxygen family and nitrogen family? Have we understood? So I have to take from the halogen and noble gases, right? Halogen and noble gases only you want to understand better, right? Or the whole thing you want me to teach again? Do you want me to teach you the whole thing again? अच्छा ठीक है. Okay. All right then. चलो. Good night everybody. Even I am going. I have to go home very hungry and can't tell you how tired I am. So see ya all. Okay. You know what? I started my classes at 12 o'clock and I still have to stay. I still have to record. So I think it's pretty much going to be a 10-11 hours of work today. So much of work today. Anyway, only from noble gases. Okay, I'll do it. Chalo, bye bye. See you everyone. See you, tata. Yes, please do send me the oxo acids. Okay. Bye bye. Lots of love everyone. Thank you. Bye.